Welcome again to the ESAFI Lab Collaborative Innovation Network Launch Event. So maybe I can start present myself. Today will be the chairman and I will give later a short speech. So my name is, here I am, it's Cristiano De Nobili. I'm the lead AI scientist at PySchool. And regarding the Collaborative Innovation Network that we call shortly CIN, together with the PySchool team, I'm behind the management and growth of the network. My background is in theoretical physics, and I have been involved in machine learning and AI for the last 10 years, basically. So what's the Collaborative Innovation Network? The CIN, by the ESAFI Lab and managed in partnership with PySchool, is a dynamic and collaborative community that brings together leading researchers, experts, and innovative talents to harness transformative technologies and accelerate and drive the future of Earth observation. So during this event, we will launch the very first calls for candidates who would like to take part of this network. So the agenda today, it's pretty dense and full of interesting talks. I don't want to waste too much time. So now I will leave the floor to Sébastien, which is the managing director at PySchool. So Seb, the floor is yours and go ahead.
Thank you, Cristiano. I will speak at PySchool to motivate what's going on there and explain why PySchool is running the CIN on behalf of ESA. So my background is in AI, in machine learning and NLP specifically. PySchool, we founded in 2017 to address one critical need in Italy at the time and in Europe, which was the need for skilled AI professionals. So we designed training programs that were based on hands-on action. We are based within PyCampus, which is a venture fund at seed level. We invest in applied AI startups. And this on the screen here, by the way, this is the swimming pool in one of our offices. So at seed level means we invest between 50 and 500,000 euros in startup companies, taking a 1 to 10% share there. And to date, we've got about 65 companies in which we invested, a healthy number of which have already died. That's part of the risk, and it's a good thing to happen in venture capital. And a good share of which is doing very well, and a small number of which is absolutely exploding, with exponential growth. Many of them are European, and currently we're seeing very many startups in which we invest jointly with Y Combinator, and so that means many of the startups are in the United States. We set up the School of Artificial Intelligence with this mission to train AI specialists with hands-on projects. And so we created a format that lasts for 8 weeks, where we have a team of engineers working on one business pain that is brought to us by industry. Before COVID, they used to come for the entire 8 weeks over to Rome in our offices and work on this project, supported and coached both by PySchool staff and by external scientific advisors that we have. These days after COVID, it's a hybrid modality in which we work. And the outcome of School of AI is that we produce a minimum viable product, a prototype, if you will, in 8 weeks, solving our sponsors' needs. And we're helped by a number of people in this adventure, I would say. So on our scientific advisory board, we have Marcello, who is a principal scientist at Amazon in Madrid these days. He's one of the most cited scientists in the field of machine translation. Hassan Sawaf, who's been the director of AI at multiple very large corporates such as eBay, at Yahoo, at AWS, and recently he started his own startup called Explain, an AI marketplace for models and AI-related assets. And then Alex Weibel, who's an AI veteran, I would say. He, for those in the know, so if you know what a CNN is, then Alex is the person who in 1983 introduced the first CNN in the guise of a one-dimensional convolutional neural network applied to speech recognition. And Alex is a professor both at Carnegie Mellon and also in Karlsruhe Institute of Technology. And then we've got a number of mentors that help us specifically on each project. Łukasz Kaiser, one of the inventors of the transformer, so one of the authors of the 2017 paper, Attention is All You Need, which gave rise to the deep learning craze that we know today. Ricardo, who's a bioscientist by training, who's then switched to machine learning. Novi, who is a professor at the University of Sussex in machine learning, and many others that are not on the slide here. So in this modality, we've trained 230 fellows who are now students and professionals elsewhere at Mila, ETH in Zurich, in Cambridge, in Google, many companies out there. We've delivered 100 prototypes because we had 100 projects like this. We handed them over to the sponsors of the program. But PySchool also does large-scale research projects. An example of this is EDIT, the project that works on the European virtual human twin, designing a roadmap together with other companies, hospitals, technical partners. It's an EU-funded project that lasts for 2 years, that is soon to close end of this year, budget 4 million euros, and PySchool works on the AI component of this project. We are also involved on a more recent project called Metween. This is a collaborative research grant that goes to PySchool and other partners, 7 million euros, 4 years. We started in January this year, and we're working on foundation models for speech. And that's the audio, the text, and the video components of speech. We've got an amazing compute grant already from an high-performance computing partner, 600,000 GPU hours. And what's exciting about the project is that all of the deliverables will be open source. So the models, the data, the training data that we use, the evaluation data as well, and the benchmarks. So follow us if you want to know more about Metween, which will be applied to video conferencing. So we've got Zoom on the consortium, and we're collaborating with them to do experimentation and research. And then a project closer to our topic today, for the European Space Agency, we're developing the Earth Virtual Expert, where this is an LLM-based Earth observation chat agent, a dialogue agent, if you will. So PySchool implements all the phases of the project there, from the text corpus collection, the LLM fine-tuning, RAG, so retrieval augmented generation, and we work on the compliance aspects, so that's copyright, GDPR aspects, and then we deploy a pilot. We started in May this year. We expect to deploy the pilot in Q2 2025, and we will reach out to a community of users, of beta users. So if you'd like to be involved, follow us, because we'll issue a call at some point for beta users of the Earth Virtual Expert. And this is going to be super exciting because, it's LLM technology applied to, what we're interested in here. So Earth observation, computer vision, Earth sciences, geophysics, satellite imagery, and all these topics. And our topic today, the Collaborative Innovation Network. So on emerging technologies put at the service of Earth observation, quantum, Internet of Things, artificial intelligence, with a goal to attract the best engineers to ESA's PhyLab. So we address students at different levels in their academic career, so both master's and PhD students, but also established and senior researchers, both in industry and academia, with a variety of schemes that we're progressively deploying. So one is the visiting researcher scheme. There's also consultancy for more senior researchers, and also joint research sprints. We expect that we'll deploy an average of 50 grants in the next 12 months on this scheme. And today we'll speak more about, PhyLab and the activities there, but also a couple of, testimonials, one from Fabio in a minute. And now I'll just hand over to Cristiano, who will give, I would say, a vision to the design of the Collaborative Innovation Network. Over to you, Cristiano.
Thank you, Seb. But before me, I would like to present Giuseppe Borghi.
Apologies, obviously,
Yes,
Giuseppe.
Giuseppe, which is now the floor is yours, which is the head of ESA Philab, and he will dive into ESA Philab mission and obviously the CIN. So Giuseppe, feel free to be on stage.
Thank you, Cristiano. Thank you also, Sebastian. I think it was very important to see what Pi School is doing with us. It's a great partner that we selected for supporting several projects, the LLM and this CIN network implementation. You have seen, let's say, the depth of technology and network into the deep tech they have, and that's fundamental for what we want to do together today. So let me share my screen and I will give a presentation, an introductory presentation. Please confirm you see it.
Yes, Giuseppe.
Do you see it?
We can see it, yes.
Okay, thank you very much. Okay, so a few words about what is the ESA Philab. ESA Philab is a division of the Climate Action, Sustainability and Science Department of the Directorate of Earth Observation of ESA. So we are a structural part of the Earth Observation Directorate. So what is ESA for the people that doesn't know us? So we are an intergovernmental organization, so we are not part of the European Union. We have been established in 1975 by a group of European countries, including also Canada now and Norwegia and UK, that they decided to establish this organization to promote a cooperation among space research, technology application, exclusively for peaceful purposes. And that's what we do since 50 years now. So just to give you an idea, we are about 5,500 workforce people, 22 member states, as I said, including Norwegia, Canada, UK. The budget for ESA on 2024 is about 7.8 billion, which correspond about 10 euro per year per European. So it's nothing. So it's less than a pizza to get all the benefit we get from space, as we know. So this is a breakdown of the budget that I mentioned before, just to show that currently Earth Observation, the directorate where we talk today, is currently the biggest one in ESA, which is driving the 30% of the activity we do. Sorry. So what is the mission of Earth Observation in ESA? So for a long time we said is to take the pulse of our planet, so to observe our planet in many different variables. But we are changing this kind of storytelling in what we call right now Earth action. So to move from the pure data collection to understand what this data can be done and translate this in real action, in real plan, in prescriptive planning of activity that human beings can do to improve our situation on the planet. So in this context, the Philab is the innovation lab of Earth Observation. And our mission is to accelerate the future of Earth Observation through two tools, actions actually. One is disruptive and transformative innovation, and the second is commercialization action. So to take technology derived from in the science sector and bring them into the commercialization arena. The uniqueness of the Philab inside ESA, it is the only organization where you can start to talk with us with a completely blue sky idea, non-qualified, really, let's say, the thinking of the last month. And we have mechanism to support the development of this idea, to nurture, to test the solution, fail fast, up to deliver the impact in the sector of reference, that can be the scientific sector, NGOs, or even into the commercial sector with the development of the product and service that is the goal of the commercial initiative. As you will see later on, we are organized in two groups. What we call the first one, looking at the initial part of this innovation pipeline, is called Explore Office, and the second one is called Invest Office. So we are in Frascati, in Italy, south of Roma. We have been established at the beginning of 2018. We have more than 20 strategic partnerships with research center, industry, and many different organizations. And we are about 40 members. I say about because we are an open lab. We have quite a lot of people coming to our lab to stay a period of time, just to work together on common interest activity. And this we call visiting researcher, which is one of the elements of the collaborative innovation network that we discussed today. Just a bit of statistic of the last 4 years, we had at the PhiLab more than 120 people coming from 26 nationalities, just to testify that we are really an open lab. And typically we have 10, 15 visiting research all the time here at the PhiLab. So the size of the PhiLab is really, let's say, changing quite a lot time to time. There are two ways to collaborate with the PhiLab. Share the mutual interest that we're discussing today, for example, as a visiting researcher, visiting professor, research fellow, or through contract. So we issue invitation to tender, we have the program of commercialization and many other, but that's not important to discuss today. Some of the successes of the last 4 or 5 years, we have contributed to about 20 satellite development at different levels. As I said, we have about 20 strategic collaboration. The size of our commercialization program, which is called Incube, is more than 200 million. And right now is about 140 activity in the pipeline. We have a publication list of more than 100, and I think now is more than 150 papers, about 10 in Natures. We have a scheme of visiting professor, and I'm happy to see some of these are with us, and we have, Roberto talking for us today. More than 17 visiting researchers we have also up to now. This is the timeline of the satellite that we are currently supporting. I will not go through all these details, but just to give you an idea. So if we focus on the Explore Office, which is as I said, the initial part of the innovation pipeline, and I give you some information what we do. So in terms of technology and internal competence that we have at the PhiLab is mainly artificial intelligence, machine learning, innovative computing paradigms, which means quantum computing, edge computing, neuromorphic computing, and other activity around IoT, augmented reality, blockchain, Web3, cognitive space, and in general, everything is linked to ICT revolution. We apply these technology elements to all elements of an Earth observation value chain, from flight hardware to end-to-end systems. So not only downstream application, but again, on any element of a space motion. Here are some examples of activity that we have done. These are experiments we have done with Italian company and Swedish company, UK company to test in orbit AI through a small constellation of nanosatellites. We have supported Thales and Microsoft in this development of this payload in the selection of AI model to be hosted on this payload, which is right now running on the International Space Station. We are now pushing a concept that we call cognitive cloud computing in space that is aimed to move, in few words, the ICT revolution that we have experienced on ground in our daily life with internet, with cloud computing and so on, from ground directly in space and to develop a fully connected network of intelligent agents with sensing capability, which are Earth observation satellites. We have worked on the capability to take information, heterogeneous information like health data, population data, climate data, socioeconomic data to, for example, quantify health risk for a specific disease, which is dengue, in 2 countries, Brazil and Peru, at state level. And this was classified one of the best UNESCO project, AI project for SDG. I received the best UNICEF research of last year and triggered a funding from the Wellcome Trust of about $600 kilo for the implementation in these 2 countries. Another topics we are working on, and we will have later on a presentation, is quantum computing for Earth observation that we have started in 2020. And a bit of words about the Invest Office. So this is the commercialization program of Earth observation. What is the commercialization program? It is a program to support company that has the intention to develop new products and services to serve a business case, okay? And in this case, we can support the company co-founding this initiative up to 80% to provide technical and business support to reduce the development risk and provide a so-called ESA step of credibility that allow in particular startup to increase their credibility toward private investor and customers. So that's it. That's from my point of view, the introduction. So the PhiLab is actually similar to many other different innovation lab where we work on an ecosystem of innovation happening mainly outside the PhiLab, mainly outside ESA. And then we try to connect all this innovation in the mechanism to be able to select the good idea and then to be able to support this idea flourishing and really reaching the impact into the society. That is our mission. And with this, I think I can conclude here and give back the word to Cristiano.
Thank you. Thank you, Giuseppe. Now it's Fabio del Frate turn. Fabio, in the meantime that you share the screen, I can say about you that you are a PhiLab visiting professor and full professor on remote sensing and applied electromagnetism at the University of Rome Tor Vergata. So please, Fabio, you can go ahead.
Yes. So good afternoon, everyone. So yeah, I'm actually working at University of Tor Vergata, which is, by the way, I think for sure, I think the nearest university to is Esrin. So you can see here is Tor Vergata University, our campus, which is a big campus, a little bit outside from the historical part of Rome. And here is Esrin. So we are very close, and this is something important because it facilitates the relationships, interactions between our laboratories, myself, and the ESA PhiLab Center. Our experience at our laboratory of Earth observation at Tor Vergata and is focused on artificial intelligence since the end of the 90s. So we had this intuition that artificial intelligence and neural network could be a very important tool, a very important way to extract the information from data which were collected by satellites and in a remotely sensed way. So this is the first paper we published. You see, it was about atmospheric profiles estimation from radiometric measurements. We are, let's say, a relatively big group where there are 3 professors. And in the laboratory, we have 6 researchers with either permanent and not permanent positions. We have a PhD in geoinformations, and so some of the, let's say, research is also carried out by PhD students. At the moment, there are 6, and then we have also master students. So we are working all together and with meetings with different line of research. And we are participating in conferences and participating in projects from ESA for European Union and other activities. As to myself, actually, I was a research fellow in ESA many times ago. At that time of the paper, basically, was in 1999. And I was working on end-to-end application Earth observation, and I was introducing actually neural networks also at that time for analysis of oil spill. I remember from SAR images. So we set up the first one of the first methodology in the detection of oil spills from SAR images using the neural networks. And then I had also through my group continuous interaction with ESA, answering exchange of students, visiting, bringing the students to see the ESA center, projects together at a different time, also educational activities. And more specifically, as a visiting professor, I get with other colleagues a formal appointment in 2021. And let's say that the activities in this regard were mainly of three types. Of course, interaction discussions with the Philabbers, and of course, I would like to continue with the people who are also participating to this meeting. Also, there were more, let's say, high-level scientific discussions and meetings with my other colleagues. With a scientific board which was created by European Space Agency, specifically for the Philab, and then I will tell something more about this. And then, of course, other activities regarding networking, doing things together, and also let people who are working at the Philab to participate in what we can have as main activities in research and also in development. Because, by the way, we have also a spin-off company which was created in 2006 called GOK. It was incubated by ESA a long time ago. And so also the research and development, bringing into the markets some products is part of our activities. As I said, we started working on AI applied to Earth observation a long time ago, and we spread our activities and line of research across many fields and across many domains. This is just where we gain experience in terms of problems, of retrieval problems or classification problems as far as land surface is concerned. On the left side, you see the input data. They usually are collected by satellites, sometimes also by ground-based instruments. And on the right side, you see the parameter that were estimated using an artificial intelligence module or system. So this is about the land surface, but we have also an experience in project in atmosphere. Of course, either microwave data, SAR data, SAR data more for the land. Here we have, yes, also in any case, radar data, because you can use a radar for estimation of precipitation rates. But also satellite spectroscopy, hyperspectral data. Basically, we are at the moment using and also making data fusion between different parts of the electromagnetic spectrum to estimate parameters like that. More in terms of air quality monitoring, but also in terms of meteorology applications. And also, other lines of research are focused on the image processing. Again, always having either microwave or optical and infrared data as a source of information, and having different kinds of products as a result of the artificial intelligence processing of this data. More recently, since a few years ago, we also added some more, let's say, activities regarding onboard processing based on AI. So far, we had some results as far as object detection or change detection is concerned, and also lastly, in image compression. At the moment, we are working with multispectral data, so image compression is performed on board, and we are now switching also to SAR data. And of course, also super resolution, so increase the spatial resolution of the data using artificial intelligence. Regarding the collaboration I had with my excellent colleagues that was mentioned before, we had a mission given to us by ESA, which was using a European Space Agency to shape elements in the context of the digital twin Earth, and with focuses on the artificial intelligence techniques, also ICT architectures and specific use cases. It was an exciting work together, which lasted at least a couple of years. We had different meetings and discussions, and you see the board, let's say the people with whom I interact on the left side, but you can find also on the ESA, on the PhilHub webpage. And okay, there were different outputs from these interactions, some technical reports, but also I would like to mention a white paper which was published recently on the use of artificial intelligence for Earth observation. It has been published, I think, just a few weeks ago, 2 or 3 weeks ago, on IEEE Geoscience and Remote Sensing magazine. It's called Artificial Intelligence to Advance Earth Observation. There are different sections regarding machine learning and computer vision for Earth observation, advanced processing and computing, knowledge-based artificial intelligence, physics-based models, and user-centric Earth observation. So I think this could be an interesting, starting point for people who are working with in this line of research, or if they want to produce products. As far as other interaction networking, I would like to mention that European Space Agency has been funding together. We work together with Sabrina Ricci of the PhilHub on this. I want to thank her also for these, let's say, joint efforts. So in Italy, we have this Earth Observation National PhD program, which is open to everyone, which is not just for Italian students, of course. And with the ESA PhilHub, we were able, ESA actually, decided to fund some of the scholarships. As a group, we are also in the IRI. The IRI is, we call it the Italian Copernicus. This is a very big investment from the Italian government. There is a launch of satellite and especially generation of products and of services. So we are in the core of this. We are producing services, and I think this could be also useful for people who want to make business with artificial intelligence and Earth observation data. So if you want to have, any kind of discussions or comparison of what you're doing, what we are operationally doing, you are very welcome. And we are also on the consortium which has been managing the FISAT-2 mission, which is an ESA mission which has let's say the aim of having artificial intelligence on board. So there are modules based on artificial intelligence which are operational on board. This has been launched just recently, so it was also a very fresh news. It was launched in August, the satellite, and we are really excited to see the first results of the first final products which are created by the routines, artificial intelligence-based routines that we put on board. And I just want to conclude as let's say a scientist, a professor, with one recommendation when we are using AI. So please do not use AI as a black box. This would be very negative in terms of the results that you may have, in terms of the services that you may provide. You always have to be aware of what you're doing. There is nothing that comes magically, and this is a cost in terms of knowledge that you have to consider, but at the end the results will be much more reliable. So I think this concludes my talk.
Thank you, Fabio. Thank you very much. Now it's my turn. I will share my screen. Hope you can see it in a while. Okay. So basically, I will give a short speech to answer why we are developing technology for Earth observation and what's the final purpose, at least for me, what's driving me. And finally, we will answer to who we are looking for in the collaborative innovation network. So basically, let's take a global view and technology about technology. So throughout history, technology has, without any doubt, driven humanity forward. For the starting from the steam engine of the Industrial Revolution to space exploration and digital innovation that basically power our world today. And in the last year, we also saw a exponential growth of AI, and who knows what's come next, you see? So basically, technology has driven humanity forward. This is without any doubt. But despite many advances, you see, technology has also taken us as a humanity a bit away from nature. We were used to live in big forests, with trees, close to nature, with a contact with nature. Nowadays, we are living in big cities with skyscraper, building. So basically, technology takes us a little bit away from nature. And you see, the farther you are from something, the more you lose respect for it. This is my view. So this could have a negative impact. If you lose respect from something because you are far away from it, then you lose also empathy. And you see, nature in the last centuries has become something to be solely exploited. And the rapid development of technology has taken us and the planet a bit out of equilibrium, in an out of equilibrium situation. And climate change is, for instance, one of the consequences. You see, in the last 2 centuries, from 280 ppm CO2 concentration, today we reached 427. And in my view, this is the fault is a little bit of technology, okay, in this storytelling. So you see, why? Because technology was used mainly for its own sake. So when technology is only pursued for its own sake or used indiscriminately, or is not developed in harmony with nature, it can become a danger for humanity and obviously for the planet, for the Earth. And it can only leave us facing significant global challenges. So, again, remind what I said before, the farther you are from something and the more you lose respect for it. But something magical can happen. If we go even farther, as in space, something magical can happen. An overview effect envelops you, envelops us, envelops humanity. And that's why space and Earth observation are a game changer as a technology. So you see, today we find ourselves, as Giuseppe mentioned in his presentation, talking about a change of storytelling in the ESA and ESA Philab mission. Today we find ourselves at a critical juncture. So the rapid emergence of transformative technology and their impact in the Earth observation sector is our best hope and opportunity to really tackle many global challenges. You see, again, in my storytelling, technology was part of the problem because we use it in losing the contact with nature. But now technology can turn out to be our best open opportunity to tackle these global challenges. And so, what are the transformative technology? Giuseppe and Fabio talk about them. Among them, there are quantum technologies from sensing to quantum computing. new innovative energy efficient or memory efficient AI models, for instance, nature-inspired new computing paradigms like neuromorphic computing, high performance distributed computing, and many other technologies that really are our hope and opportunity to improve our planet, improve our connection with the planet again. And so why the CIN? The CIN is born basically for this, to bring together the greatest brilliant people, explorer of ideas, to collaborate together as a PhilHub, to be, let's say, a vehicle for change using the most advanced disruptive technology to advance and drive the future of Earth observation. So this is my opportunity to, tell you to check out the Collaborative Innovation Network open calls. You can find already an open call there, but there will be many more in the coming weeks and months and throughout this project. So I leave you some seconds to take a picture and save the web page. And given that, I now would like to let's say introduce the more technical session, starting basically from now, and leave the floor to Alessandro. I think he will speak about quantum computing for Earth observation.
Yes.
So Alessandro, please. Okay, thank you.
Can you see the screen, right?
Yes, I can see.
Okay, perfect. Thank you. So, hello everybody. I'm Alessandro Sebastianelli. I'm currently a research fellow at the ESA PhilHub in the Explore office, and I'm the one working on quantum computing for Earth observation. And today I will give you a brief overview of all the activities we have done in this field. So let's start with a panorama of the currently explored technologies in Earth observation, quantum technologies explored at the PhilHub. So essentially, we are looking at, for now, quantum computing, quantum computing for you, with the aim also to expand to more technologies like sensing or communication. And we do that in three ways. One, by issuing contractual activities. The other one about doing exploratory activities, so more scientific works, I would say. And the third one by connecting people. So why using quantum computing and quantum machine learning? So essentially, as also Giuseppe mentioned, we are now looking at, we are transferring our motto from Earth observation to Earth action, and combining both the software revolution and current hardware revolution is, let's say, an extremely powerful way to do this. So which are the expected advantages of quantum computing and also in quantum computing for you? For sure, it's speed. So essentially, this will help us in processing in a faster way, also in a more efficient way, the big volume of data we are producing every day. For sure, also improving accuracy of our models. And with this, we are both talking about purely quantum models, but also a solution like quantum machine learning models. Increase the efficiency, and with this, we are talking about running things in parallel, but also trying to do it in an efficient way, looking also at somehow the green aspect of this new computation paradigm. And also open new opportunities. So try to solve problems that currently are not possible to solve. So which are the major achievements at the PhilHub at the moment? So we started, as Giuseppe said, in 2020 at the Phi Week, and there we launched the QC for Your initiative. I put this in, let's say, in the scientific aspect, even though it is open the possibility also for the more contractual aspect. Indeed, this graph is split in two parts. So from that moment, we had an escalation of activities, starting with on the contractual aspect with OSIP, and I will talk about that later on a bit. Creating partnership with several entities like CERN, universities, and so on. And we started publishing the first papers. That currently is the most cited paper in the field of Earth observation. Later on, we started with more advanced contractual activities, the ITT that we launch typically, focusing mostly on let's say, studying this technology. And now we are expanding this with something more advanced. And during this time, we also, on the scientific aspect, we also issued the library that everyone can use. So everyone can now start working with quantum computing Earth observation quite easily. And we increased our publication by, let's say, a fair enough factor. Also trying to grow our connections. So we reached almost 40 partners working with us on this topic. For the future, we are, as I put here, we are entering the ChatGPT era of quantum computing. So everyone is talking about this technology. Everyone wants to do something with this, and there are a lot of funds that have been put to advance this field. And I mean, we are also trying to, on the scientific aspect, to create more and more connection through, for example, technical committee in IEEE GRSS, but also being at big conferences and events. So, a few words about the conference. I don't want to bore too much, but most of our knowledge is also derived from this. The first, let's say, more structured one, was about the identification of useful use cases, define which hardware is more suitable for Earth observation, and derive a timeline with also industry map. And the next one that is going to happen soon is mostly about implementation of these use cases on real hardware, but also in simulation. And we've done this with the list of partners you see here. And I mean, we have also always the spirit to increase our collaborators. So let's say the main output of this was the creation of this kind of map where you can see that there are, for example, some activities, some use cases that can be already implemented into some, let's say, basic hardware, even though we are still in the NISC era. There are some activities that can be implemented in the near future, and others that needs more advanced computing resources. But this is a pure speculation for now, and this period can be compressed a lot if there will be a big tech revolution. So about us, if you were to this is mostly it's for sure more of interest. This is a way of collaborate with us, and it is mostly devoted to PhD students and also more senior researchers. And I mean, it's a call where you can apply. We have several of these currently running on the field of quantum computing. I don't want to read the list, but we are trying to explore several use cases and also the technology from several angles. So knowing that, what we discovered is that currently, given some limitation of the quantum hardware, and also given the fact that Earth observation it's really a huge program. We have plenty of data, a lot of interaction to discover. We end up in this kind of hybrid performance computing for Earth observation, where we combine several technologies ranging from high performance computing to quantum computing, neuromorphic computing, trying to get the best from all this big family of new computation paradigm. Also, in this case, we are doing this with several partners that are helping us in also defining the roadmap. Okay, more on the scientific aspect. We opened recently this Python library. You can install it. Maybe this is more for the, let's say, for the students. You can install it easily via the classical Python tool. There is also a tutorial that is still running. You can go to this link, so you take a picture if you like. And this library is more or less a collector of all the activities we are doing, the scientific activities and efforts on QC4U. And mostly we divide these activities into main groups. One is application-driven research, where we do classification, detection, noise filtering, generative AI. On the other side, we have more fundamental research, where we try to explore and to exploit all the quantum advantages inside maybe layers. For example, try to transform a classical neural network in its quantum version, as well as for the convolution and so on. And I can say that, especially for in the field of QC4U, we are currently leading the research. We have quite a relatively big number of publications, also because the field is quite narrow and also new. So yeah, our first paper was this one that you see here that reached 96 citation in these days, and is the most cited work in the field of QC4U. And also to have more impact on the research side, we are soon will be part of this new IEEE JRSS technical committee, and we will be leading the quantum computing for your working group. So our network has grew a lot in the last few years, and as you can see in the picture, we have Europe is the most activated one, so we have a lot of collaborators from Europe, but we are trying to expand our network also outside, and most of our collaborators sorry, came from a research center and academia. We have also a spike in industry. That's mostly because of the ITT that we have. So the current team is this one. I saw that we have at least two visit professors that joined the event, and probably also some visiting researcher. And yeah, but I mean, we don't put limit there. We are happy to collaborate with everyone. And I mean, the field is super narrow and super new, so there are really a lot of things to do. How to get you on board. And just to conclude, we are also trying to expand a bit our horizons. As I said at the beginning, we are looking at quantum technology for Earth observation. So we opened this position that is an international research fellow position. So it's a postdoc position, but at international level, looking at people from South America and Indo-Pacific country. So if you want to apply, please take a screenshot of this slide. And with this, I conclude. Thanks a lot.
Thank you, Alessandro. And now I would like to leave the floor to Gabriele Meoni, which is Innovation Officer at the European Space Agency. Please, Gabriele.
Can you see my screen? Okay, thank you everyone.
Yeah,
My name is Meoni, I'm Innovation Officer at the Philab. Thank you for your introduction, Cristiano. So today I'm going to spend some few words on edge computing and why we are investing the Philab on this kind of computing paradigm. So when we talk about edge computing in general, we talk about processing close to the sensor, and in this specific case, close to the sensor that we have on board satellite. So we are talking about onboard processing by using mostly artificial intelligence techniques. So, okay, I will spend some few words on why we would like to do onboard AI and the motivation, the application, and the challenges. I will review some internal activities. So, of course, we also do industrial project on this kind of topic, but since we're talking about collaborative innovation network, I prefer to focus on the research that we're doing internally, and also mention what could be project relevant for future visiting researcher on this topic. So let's start with the motivation. Why onboard AI? So I would like to explain you this by discussing the current classical band pipe architecture that you have to download the data. So in a typical classical mission that can be, for instance, Sentinel-2 that you see here, use this kind of approach where you have some satellites that are basically the white dot that you see in the GIF that can only send the data when they're close to the ground station, that are basically the red data. I mean, for Sentinel-2, that's not exactly true, but in most of the cases, that's exactly the case. So what it basically means that you collect the data and then you send all the data to the ground with no possibility to pre-filter the data. And in particular, if you have an event that you would like to react very quickly, you can see that in the worst case, you need to wait for the satellite to do all the round around the orbit and then download the data when close to the ground station. So it's not exactly the best approach to react quickly to events that need fast response. So why edge computing then? Why onboard AI? Because edge computing gives you the possibility to pre-filter the data on board and to get conscious about the fact that you need to have an event to react. The typical example is natural disaster, for instance, a wildfire or something like that, to which you want to collect and extract actionable information quickly, and using additional communication infrastructure like inter-satellite links, send the information very quickly to the Earth. So as you can see, we are not disrupting the paradigm, but we are just complementing, adding one branch, the one to the left, where the information goes quickly to operational services or generic end users. And why AI? Because AI has been demonstrated one of the best tool to process that observation data, especially in the last years. And one of the application that you have in mind is pre-filtering the data, but also send early alert for natural disasters like volcanic eruption, wildfire, oil spill, for which you want to have a reaction quickly to limit the damages, also to save life if possible. But there are also more, let's say, futuristic things, what is called novel acquisition systems that we are now focusing nowadays, that is not focusing only on a single satellite, but on distributed intelligence. So if you take a look at the left, let's suppose you have one first satellite that can look and scan a very big portion of the Earth. But since the portion is very big, typically you cannot have a very high spatial resolution. So you might not be able to see very well what is there, but you might be able to see quickly because the satellite needs to do less orbit to process the image. When you scan an event, you could tip, so ask another satellite, when you pass there, just look at that area. And if you have a satellite with a smaller, it's called swath weight, so area that is scanned, but with higher resolution, you might have higher resolution scanning and also frequent scanning that allows you to implement novel acquisition systems with complementary basically skills that you will not have with only one single satellite. Of course, nowadays, there are a lot of applications in mind. There are a lot of potential, but there are still a lot of challenges that needs to be solved. So one of the challenges is the communication constraint. You need to be able to communicate. You need additional technology like inter-satellite link that needs to be explored. So it's not only a matter of AI. The challenge is more complex. But also you have power limitation, especially if you have smaller satellite. You need to dissipate as least energy as you can. Otherwise, you might have thermal management problem or simply you cannot have enough energy. And also you might have radiation problems and other mission-specific constraints, but also limited data set representativity and availability. When you process on board, you don't have the same quality that you have on the ground. And since the payload data handling approach is quite novel, typically you don't have the same data, a lot of data set available that you will have on the ground. So just to mention one of the internal research activity, I want to focus on this aspect. So on the problem of power constraints, but also limited representativity. When you process data on board, you would like to process data as much as closest to the sensor as possible. So basically, you don't want to process the data too much as you do on the ground because you cannot afford because of power limitation. So you would like to process what we call the raw data. But unfortunately, raw data are not really available today because so far, the end user, when they process on the ground, wants typically well post-processed data, not the one that you have to process on board. So one of the questions that we had, can AI be able to be trained to process directly the raw data without doing all the post-processing that you do on the ground? Can I minimize the pre-processing to react quickly and to do it with few energy? So to do that, we created a data set that is called TROS. So this data is the thermal hotspot on raw Sentinel-2 data. When we call raw Sentinel-2, we call it the compressed level 1.0 data that are not nowadays available to the end user, except for this data set and few others. And as you can see, the raw data looks like the one that you see on the left in the image. So it's not really easy to see what you have there because the data are not spatially registered and also have some other problems due to the lack of calibration and other not really nice effects. And what we also did, we also implemented a Python packages to process the raw data and to do all the steps that you can see on the image, starting from the raw and to have a very lightweight but quite efficient pre-processing that you could do it on board. And also, we tested this on a real hardware that is being flown, or at least is will be flown soon in space mission. That is the Ubotica Intel Myriad X device. So what we did in collaboration with Ubotica, we start from the raw data that you see on the left. We apply a very lightweight registration where the different bands are just shifted one on top of the others. So no real fancy computer vision. And then we crop the images into small square that we call patch, and we label them if they are containing fire or not fire event, or volcano or wildfire. And we are able to do all of this in an image that is more or less 2000 times 2000 in 1.8 seconds. So it's very quick, much lower than the time that you need to produce the data on board. And also having a power consumption of 6 watts is very few. So just to mention one activity, we're not doing only this on multispectral images. So we have some research also on SAR data. And I want to conclude this just to mention some project that we are doing in collaboration with Visited, what we would like to do. And we're actually doing collaboration with Visited Researcher. So we have different topics, edge computing with novel application, novel acquisition systems. So we would like to experiment with a bit with DeepNQ and other acquisition systems, edge computing hardware benchmarking, narrow architectural search for energy efficient, and then domain gap and domain adaptation solution, and many others. So if you're interested, don't hesitate to contact me or pass through the CIN to do that. And thank you for your attention. I'm happy to provide more information if it's needed. Thank you very much.
Thank you to you, Gabriele, for the interesting many application, exciting ones. So now we can go ahead with the last technical talk that will be done by Patrick Ebel, which is an internal research fellow at the European Space Agency. I will leave you the stage.
Yes, all right. Thanks a lot. I hope you can hear me properly and see the screen as intended. So I'm aware this is kind of like the last technical presentation on the program, so I'll keep it a brief overview of 3 ongoing activities we're having here at Phyla. And just to give you an idea, so we mostly take a look at the pictures here. It's going to be very relaxed and easygoing. One activity we're having internally here at Phyla is called Major Tom, and it's the idea of having some kind of like a meta data set, which is providing the framework for other researchers with remote sensing practitioners to derive their own data sets, subsets of this data from. So the idea here is to define some kind of like outline and format which allows people to take part of this data from the locations or the time points and use it without kind of like reinventing the really new reprocessing all the data, but kind of like making quick access to the existing Major Tom data set and having something that is machine learning ready, so to say. And so there's this core part of the Major Tom data set that we are currently having. It is based on Sentinel-2 observations. It covers 50% of our entire planet. And it's about 2.25 million images, 2.5 trillion pixels, and almost 50 terabytes of data. So they defined on a grid such that it's easy for people, researchers, outside of Phyla as well to reuse that data, to define their own grids, to share their definitions of their subsets of the data with others. And the idea is to make the data set more approachable and to facilitate replication of ongoing research. So currently, and since its release, Major Tom is trending on Hugging Face, and so you can follow the activities of Major Tom on Hugging Face by using this QR code here. And actually, so since this slide was created, so many kind of like news have happened. The data set is expanding in different modalities. DEM, for instance, is one of these examples. And the idea is to expand Major Tom and facilitate access to multi-domain, modal, so observations for Earth observation and facilitate data set access in a machine learning ready format. This is one activity we're having at Phyla. The other one is more targeting short-term or medium-range forecasting of natural hazards. So this is specifically about floods, we are integrating geospatial data, satellite observations, and AI approaches to model floods, specifically coastal areas, because that is a region which is particularly affected by climate change. So sea levels will rise, but at the same time, there's more and more population nearby the shores. And so this is kind of like a topic which is already quite important, but will grow more and more important of the future. So it connects well to some of the activities, accelerators, and other initiatives we have at ESA and outside. And so what we've been doing here is to create a big data set for modeling and monitoring in situ tidal gauge data in the proximity of tropical cyclones and hurricanes, to have also this kind of data combined with assimilated atmosphere data and as well as ocean simulations. So we have a neural network design which combines these different sort of observations and then takes it from there to forecast extreme storm surges and ocean level few hours, let's say 8 or 12 ahead in time. And so this is one of the ongoing activities in this regard that we have at FileUp. And for final project that I want to introduce you to, this is about solar energy forecasting. So the thing is, if we take a look at the sky, as you see on top here, then there's a huge fluctuation over time of the amount of solar energy that is being created and that can subsequently be absorbed by solar cells, photovoltaic, and so on for industrial usage. And so what is having a big impact here is the daytime, but also the coverage of clouds in the sky, which impedes the absorption of solar energy that is available for us. And so this is a big challenge, of course, for energy parks, so solar parks, which want to capture the solar energy and then provide it to industry, for instance. And one approach we follow here at FileUp and with external partners to make this more predictable is to combine observations from satellites, such as, for instance, ones that EUMETSAT is operating, so weather satellites, but also ESA's Sentinel-2 satellites, and the top view on the planet on the cloud coverage is combined with these ground cameras here. So they are called sky cameras. So they observe the cloud coverage of a particular point in space. And the idea here is to correlate that and have a neural network learn how to predict the future cloud coverage over a particular region of interest. And from that, so for the sake of like actionable kind of like deductions from this outcome, we can then estimate what the energy production at one particular point in space and time can look like. So this network is being used to model the cloud coverage. And so here's an example result. This is the input, and the prediction of relating this to the satellite view is what you see on the right-hand side. So that was a very quick animation. But this is to give you an impression of this third project we are following here. And that's all from my side. Thank you.
So thank you, Patrick. And thank you to all the speaker for, let's say, their interesting talks. Now we can open question and answering session, a short one, but we'll be there. And feel free to ask anything regarding the calls, any question for the speaker, even technical. Feel free to write it in the chat or to, if you are allowed, I'm not sure, unmute yourself. In the meantime, during the talks, I have posted in the chat a couple of links for the calls, for the social media channels to follow, where we will advertise future opportunities. So make sure to save them. So let's start with question and answering session. So, okay, thank you. I'm reading the chat. Maybe I can read the question for everybody. Then feel free, the other speakers or Giuseppe, or to answer if you feel you have the answer. So I have no microphone. Sorry. what is the expected time contribution for PhilLab members? Maybe Giuseppe or Alessandro can.
Definitely, I can take this step. Okay, so it really depends on the kind of collaboration we are talking about. So in this case, here we're talking about two frameworks. If you look into the call that has been presented by School of the CIN website, visiting researcher and consultancy. So visiting research is a scheme where we host person that has, let's say, typically a strong interest to interact with the team here in ISA, in Esrin, because it's a period of time where there is a lot of exchange of information. And what we observe that typically these these people stay almost 100% of the time at the lab, exactly because they want to maximize the interaction and the exchange of information. Again, visiting research is not a structured and contractual relationship. It's really based on common interest to deliver a project, assess a technology, explore idea, and so on. It's really based on common interest. Different is the consultancy agreement, in which we are looking for different kind of consultancy, which is to have expert, to have, let's say, mentor personalities, or let's say in general people that has, let's say, a deep understanding of the technology. In this case is we're talking about innovative computing paradigms. The level of effort there is, I would say, to be negotiated on case by case, because could be, let's say, provide support to the PhilLab in defining element of the research agenda, okay? So which could involve, for example, have a workshop, either in remote or to have workshop here at the PhilLab in ISA, or to write a white paper and collaborate writing white paper, or really have a kind of mentoring for our research fellow or for staff in ISA that are looking to explore a certain technology. So could be a certain allocation of time per weeks or per month. It's something I would say to be discussed on case by case, but just to give you an idea, it's not a full-time involvement that we are looking for in the case of the consultancy agreement.
Okay, thank you, Giuseppe. There are other questions. One question is if there is any scope for founding and mentoring for developing digital tools for sustainability, obviously related to Earth observation, within any of the members of lab institution. Thanks, Nizari. And
So I try to get also this question. Let me read it again. Is there any scope for funding and or mentoring for developing digital tools for sustainability, which would have Okay, so in general, I think we are coming out a bit from the scope of the CIN, the Collaborative Innovation Network. If we're talking about funding, there are several schemes of funding that ISA in general and PhilLab as well is putting in place to support this kind of development. That goes from the full funding, typical of some calls like the Open Science Society, to co-founding in case this development has commercial meaning and commercial interest. But the answer is certainly yes. There are different mechanisms depending on what is your goal. So it's better to discuss case by case what you are looking for, what you are trying to obtain, and then we can support in the selection which is the best tool to be used to support this kind of developments.
okay, thank you. There is another question for the consultancy scheme. What is the price paid for consultancy? I don't think here maybe it's the right place, but and depends on the level of expertise. And are you interested to have expertise on data space and cloud? Again, Giuseppe.
In general, yes. It depends what do we mean data space. We are, Earth observation is just a small element of the data industry. So anything has to do with the data industry, which I think what you are referring to, data space and cloud, is for interest if it is disruptive innovation. So what is not the mandate of the FILAB is incremental innovation. We don't do incremental innovation. There are other organizations in Israel that does a lot of this. We focus ourselves in the high risk, high reward things, where we can fail, but if we don't fail, we change the context.
Okay.
So the answer is yes, if it is the English.
Okay.
And I'll just complete your answer, Giuseppe, by pointing you to the application page, where for consultancies, you can actually specify what the domains of expertise are that you bring to the table. And so you can actually sort of develop your own argument for why there should be a consultancy on that specific topic that you're proposing.
Okay, thank you, Giuseppe and Sebastian. Okay, there is a new question in the chat. I'm curious to learn more about the ESA EVE, Earth Virtual Expo project with PySchool, as I'm working something similar in my PhD. Exactly. So, can you share more about that? I would say maybe this is not in this event. We cannot dive deeper into the ESA EVE, but feel free to write us, to write me, to write through the link we shared, and we can answer to this question.
In this case, Saba, why don't you write directly to us from PySchool, as this is a bit of an incidental. It's a PySchool activity and not a CIN activity. Sure. Thanks.
Exactly. So thank you. If there are other questions, we have still a few minutes. So, or again, if feel free to write us. We share the LinkedIn page, the Twitter page of the CIN. You can message us, and we will be happy to reply. So from Georgia, I have a technical question about onboard data processing. Are you already considering some frameworks to mitigate the radiation effect that can happen in the AI machine learning models? So this is a technical question for one of the speakers. So maybe Gabriele or exactly, I think you can answer.
So at the FILAB, we are not doing much about radiation, but this is a topic more related to hardware aspect investigation that we typically do in collaboration with other ESA experts from different sections. So at the FILAB, not directly, but if you are interested, we can collaborate in this and put you in contact with the relevant expertise for this. Because of course, it's a dear topic, especially for the colleagues from the hardware division, let's say.
That's probably, Gabriele, let's say exactly, it's a very good point. So the FILAB, what is good at FILAB? The FILAB is good in connect people inside and outside ESA. So the things we do, as we tried to express before, are not just related to data processing and so on, but we act as a kind of hub looking for the competence and expertise for sure inside ESA and outside. So a question like this is not something we address directly, but we call our colleague in the Netherlands, in Estek, where they have activity running, and we know who are these people. They are experts in hardware for edge computing. We collaborate with them in order to find a solution of this question. Okay.
Okay. So, yes, the slide will be shared in the next days, as Lucia just replied. Maybe there is time for another question, if any. Okay, maybe not. If we have a patent, can we still look for collaborations?
Absolutely yes. If the underlying question is who maintains the ownership of the IPR remain with you, as is a general policy, especially if the collaboration is on visiting researcher scheme where there is no exchange of money. So we are not paying you to work with us, but is again only on pure scientific, technological, and project interest. Everything remains with you. This is even true if there is, let's say, a contractual relationship between ISA and an organization. And at the end, typically the IPR remain in the organization with some, let's say, I would say caveat.
Okay. So, is there any work or foundation model for geospatial and remote sensing data and application, such as Presto? Okay. Maybe I can say something. Yes, there are some of them. So I'm specifically talking of pre-trained large language models, or mostly text one. We are working on one of them, as mentioned before, about instead image and visual pre-trained model. I'm not expert on that specifically. Maybe I can leave to answer the other speakers, but yes, they are popping up, a lot of them, and I'm sure that one of the speakers maybe can add more about images and pre-trained model for geospatial and remote sensing.
Yeah, to briefly wait in on that. So we have research fellows who are like active inside PhiLab to develop a suite of benchmarks for image-based foundation models. So I can look up kind of like one of these, where I can post a link in the chat after. And the idea here is that we have different benchmarks which are of relevance for EO applications, and then the Earth observation foundation models can be benchmarked on these downstream tasks and evaluated. It's like one of the activities that we are having at PhiLab, for instance.
Yes, just to add, give a comment in the chat. The model Privy, for instance, was released, if I'm not wrong, 2 weeks ago. So basically, they are popping up on a weekly basis, and yes, that was a collaboration from IBM and NASA. Yeah.
And I can add that we collaborate directly with this group in NASA, which is behind the Marshall Space Flight Center. And I take also the opportunity to reply to Annalisa. So the question is, there is any restriction nationality of PhD researcher visiting PhiLab? So no, there are no restriction because there is no exchange of funding. So it's not, we don't have typical restriction we have when we exchange funding. So we are looking to work with the best talent worldwide. Okay, and doesn't need to be a PhD researcher. Can be, let's say, even more senior or less senior. But what we're looking for are two things. So one is competence and interest to work on our topics along our strategy. And one key criteria for us is to have somebody in the PhiLab or in ISA in general, to find somebody that is willing to cooperate with the PhD researcher that want to come to PhiLab or ISA. Because we want to guarantee that there is a true exchange of knowledge, information, and so that's what we require. I would say, two important criteria. Nationality is not. We had people, as I said before, from 26 countries, many outside of Europe.
Okay, thank you, Giuseppe, and thank you, Sebastian, that shared the list. I knew we had this list, but I was not able to copy and paste from our documentation because we are actually working on this topic. So thank you, and we are perfect in time. I think we can quit the event. Again, if you have other questions, feel free to write us. And thank you again. It was really a pleasure for all of us. Again, just to summarize, the Collaborative Innovation Network, shortly the CIN, by ESA Lab and managed in partnership with PySchool. You understood is a dynamic and collaborative community that aims to bring together leading experts, researchers, innovative talents, you see, to harness transformative technology and drive the future of EO. I want to invite you again to check all the open calls. You will find in the next weeks and months new ones. So make sure to follow the social media pages. And what else? Let's drive together. Let's do our best to drive together the future of Earth observation. Thank you again to all the speakers, to everybody, to the attendees, and hello, bye-bye.